Today I will start linear programming by simplex method. In my previous lecture, I have taught you about the graphical method which is used to solve the linear equation when we have two decision variables like x1 and x2. But when we have more than two decision variables, then we can use only simplex method. So this is the simplex method that I am going to teach. Today, let me work out one problem that we know that for each problem we should have one objective function. So an objective function is denoted by capital letter Z, and that objective function should be the problem of either maximization or minimization. So let me solve out one problem of maximization first. This is the simplex method, and first is the maximization one. Number one, maximize Z is equal to 10x1 plus 20x2. This is the objective function that we need to solve. Maximization means maybe the profit. We have to maximize the profit so that we get the optimum values of x1 and x2 and subjected to constraints. What are the constraints? Subjected to constraints 3x1 plus 2x2 less than equal to 1200. Then another constant is 2x1 plus 6x2 less than equal to 1500, where x1 is less than equal to 350 and x2 is less than equal to 200. So we are having four constraints, and where x1 and x2 are greater than 0. So this is the problem given to us. If you can see that in all the constant inequations, these are known as the inequations, we have less than equal to symbol. And for maximization problem, we should see that all the symbols should be less than equal to. And if there is any greater than equal to or only equal to symbol, then we have to convert to less than equal to symbol. But in case of simplex problem, in simplex problem, symbol is usually given in less than equal to symbol. When there is a mixture of less than equal to and greater than equal to, then it comes your dual simplex method that I'll teach you in the next lecture. First, in the simplex method, all the constants are of less than equal to symbol. Then the first step I have already told you that we have to convert the all inequations into equations. So how can we convert? We can convert 3x1 plus 2x2. We will add slack variables s1, s2, s3, s4 as the slack variables, so that this inequation becomes equation is equal to 1200. Similarly, 2x1 plus 6x2 plus s2 is equal to 1500. Similarly, x1 plus s3 is equal to 350. x2 plus s4 is equal to 200. So these are the four inequations we have converted to equations, and where s1, s2 and s3, s4 are, where s1, s2, s3 and s4 are slack variables. And now z, now we can add z. It has slack variables has no value. We used to give 0 coefficient. So now we can arrange z also in terms of slack variables. Z is equal to 10x1 plus 20x2. It was given to you, plus 0s1 plus 0s2 plus 0s3 plus 0s4. So this is the equation we have got for Z. Now what we will do here, CJ, that the maximization means maximization of profit is a term we will be using. Contribution to total profit, and ZJ, gross profit. So so you can see that now we will prepare one table. CJ, we will solve a mathematical way. This is for x1, x2, then s1, x1, x2, we have up to s4, s2, s3, s4. CJ is the contribution to total profit, and x1, coefficient of x1 in Z. Z is your 10, you can see coefficient of x1 is Z. Z is 10, x2 is 20, and all these are 0, 0, 0, 0. Then this is contribution quantity. What is the contribution quantity? Let's say contribution quantity, and here one term is there, minimum ratio. Now first we will go for one by one all four equations. Zero, 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 zero. That means here we have S1, S2, S3, S4. Coefficients of all S1, S2, S3, S4 are 0, 0. That's why we have put like this. The first equation is, in the first equation is our coefficient of x1 is 3. It is here it is 3. This is the Z part, and here we will put all equations. The coefficient of x1 is 3, and here in the first equation we have only considered s1. That's why here solution mixture we have s1 and its coefficient is 0. Then for x2 it is 2 and s1 it is 1. So it is 2, 1, 2, 1, here all 0, 0, 0. And what is the contribution quantity? It is 1200. 1200. Similarly for S2 it is 2, 6. Here S2 is 1. S2 is 1, all others 0, 0. Then in the third case S3 will be 1 and S4 is 1. What is the contribution quantity? 1500. 1500. Then for S3 it is 1, 1, 350. It is 1, all other things 0, 0, 0, 350. Then S4, S4 it is S2, there is only X2. X2 is 1, that means S1 is 0, 1, all zeros, and its coefficient is 200. 200. So we have prepared the table. So next what we have to do, we have to compute ZJ, that is the gross profit. So we will make ZJ net profit. How we can compute ZJ? We will compute with here 0 into 3, 0, plus 0 into 2, 0, plus 0 into 1, 0, plus 0 into 0, 0. All summation of all these things we get 0. Similarly for x2, 0 into 2, 0 into 2, 0 into 2, 0, plus 0 into 6. So in this way you can do that. Then here in this case, similarly for here also you will get 0. All you will get 0, 0. So this is ZJ. Now this is the CJ values. This is the CJ values, and this is the ZJ values. Now you compute. Now this is the formula. You should compute CJ minus ZJ. So it is 10 minus 0. It is 0. So you make it all boxes like this. So it is 10. 10 minus 0, it is 10. 20 minus 0, 20. All here 0, 0, 0, 0. So now the rule is that key column for maximization problem, key column is the column with largest positive value. I'm writing down the rules here. Here you can see maximum value is 20. So this is the key column. So here some rules are there. So first one is that key column column with largest positive value. So in this case you can see that it is 20. It is this 20. So this is the key column. It is key column. Then what to do? Divide each amount in the contribution quantity by key column and choose the smallest value. So next step is that we have to, you can see that here this is the contribution quantity. So divide the contribution quantity by the key column element. That means for first row it is 1200 divided by 2. For second it will be 1500 divided by 6. For third it will be 350 divided by 0, and for fourth it is 200 divided by 1. That means divide the key column element divide the contribution quantity by divide the contribution quantity by key column element and choose the smallest value. Choose the smallest value. Let's say we will do it now. Now 1200 divided by 2, so it is minimum ratio will be 1200, and compute the minimum ratio. 1200 divided by 2, it is 600. Next 1500 divided by 6, it is 250. Then it is 350 divided by this 0, 350 divided by 0, it is infinity. Then it is 200 divided by this 1, 200 divided by 1, it is 200. So now we have determined the minimum ratio by dividing the contribution quantity by the key column element of that row. Now we have to choose the smallest one out of these, and you can see that the smallest is 200. So this is the key row. This is key row. Now where the key row and key column intersects, that you circle it, that part. That means this is the for S4, that means, and it corresponds to your x2 decision variable, and it shows that S4 will be replaced by x2 in the matrix. And so we will divide all the values by the intersection element. This is known as the intersection element 1. Now from this it is clear that x2, S4 is the outgoing element. S4 here, this S4 is the outgoing element in the matrix, and it is replaced by x2, and replaced by x2. Now we will make another table, and we will divide. Then rule is that divide all the values of that row, that means S4 row, of the row S4 containing row, by intersection element 1, by intersection element. And what is the intersection element in this case? Intersection element is the 1. 1 is the intersection element 1 that has been circled for this problem. For other problems maybe some other value, but here we have the intersection element 1. So now we will make the next table. Again we will modify the table, make a new table. Here you can see that I've prepared all the tables, and same thing, contribution quantity, minimum ratio. Cj solution mixture x1, x2, s1, s2, s3, s4, contribution quantity, and here it is your minimum ratio. Yes, now it starts now. We'll make the rows. Then we can see that, so here x1, x2, it was your 10, 20, 10, 20, it was all these things. 0, 0, 0, 0. Okay, now first we will start with S4 row. We have to divide each element of this row by the intersection element 1. That means 0 by 1, 1 by 1, 0 by 1. So it will remain same for this case situation. So S4 will be, I'll write down or, and X1 is replaced by X2 now. It is X2. X2. I've told you that S4 is the outgoing element and X2 is the incoming element. What is the coefficient of X2? It is 20. So now X2, its coefficient will be 20. So it is the outgoing element. We will start from here. Then dividing all the elements by the intersection element, we will get 0, 1, 0, 0, 0, 1. And for contribution quantity also it will remain same because 200 by 1. So it is 200. So this is the first step that we have already done. Next we'll come to one by one. Next we have to determine the updated S1 row, updated S2 row. We have to determine the updated S3 row. So I am telling a general formula for updating S1 row, and the same thing will be followed for the remaining rows. For what is the formula for updated S2, S1 rows? And here we know it's all contributions here S1, S2, S3. Here its values are, or coefficients are 0, 0, 0. Now updated S1 row. It is equal to old S1 row minus intersectional element of old S1 row into corresponding element of new X2 row. So you can see that. So what is the, so we'll see old S1 row. What is the value? So we'll put at a time, we will do for all. So it is 3, 2, 1, 0, 0, 0, 1200. So we are putting it all at a time together. You can do one by one, so it will solve your problem. 3, 2, these things you can do at your rough. 3, 2, for your understanding only, I'm writing it down. 0, 0, 0, 1200. So you can see this is the old S1 row. 3, 3, 2, 1, 0, 0, 0, 1200. Old S1 row minus intersection element of old S1 row. What is the intersection element of this row? It is your 2. You can see that this 2. This 2 is the intersection element of, starting from your key column, it is indicating up to 2. So this is 2 is the intersectional element of row S1, 6 is the intersectional element of row S2, and 0 is the intersection element of row S3. But here as we are considering the S1 row, so this is the 2. So minus 2 into corresponding element of new X2 row. What is the values of the new X2 rows? You got 0, 1, 0, 0, 0, 1, 200. So you write down 0, 1, 0, 0, 0, 1, 200. So that's why you have to first compute this row. Then after that, using this new matrix, you will get it. You'll put it the values here, and now if you solve this, you will get. So it is, first case it will be 3 minus 2 into 0, 0. That means it is 3. Second, it is 2 minus 2. It is 0. Similarly, 1 minus 0, 1. Likewise, if you do it, you will get up this much. This is 1200 minus 400, it is 800. Now put all the 3, 0, 1, 0, 0 minus to 800 here. we'll put it here. 3 0 1 0 0 minus 2 800. We have put it like this. Similarly, for now we will compute for S2, updated S2 row. Updated. These things you need not to write, it is for your understanding only. It is equal to, what are the old values of your S2? Old values are 2 6 0 1 0 0 1500. So these things I'll write down. 2 6 0 1 0 0 1500 minus intersection element. What is the intersection element? You can see that the intersection element is 6. You can see that here. Intersection element is 6. So now I'll put 6 here. Then what old similar, these are the values similar. It is fixed 0 1 0 0 0 1 200. So you will get 2 0 0 1 0 minus 6 300. This you can do one by one, but for your simplicity I'm writing down all so that you can work out. These are the rough parts. So it is, you put all the values now. It is 2 0 0 1 0 minus 6 300. Similarly for fourth, for S3 also you will do likewise, and it will be 1 0 0 0 1 0 350. So now you have filled all the matrix. Now likewise you will do compute ZJ and CJ. So now you compute ZJ and CJ. ZJ, then it is CJ minus of ZJ. This as usual. What is ZJ? It is 0 into 3 plus 0 into 2 plus 0 into 1 plus 20 into 0. So it becomes 0. Likewise, for this one, 0 into 0 plus 0 into 0 plus 0 into 0 plus 20 into 1, it is 20. Similarly, you will do workout for all the columns. Now, CJ values are 10, 10 minus 0, 10. 20 minus 20, it is 0. Likewise you will put it, and here it is 0, it is 0. And for S4 it is minus 20. S4 it is 20, so it is minus 20. You say it is 0. S4 it is all 0 0 20 into 1 20, and 0 minus 20, it is minus 20. So what is the rule for maximization? Remember that this is for maximization. For maximization, different selection rule is there, and for minimization, different selection rule is there. This video I am doing for maximization, and for maximization rule is that we have to choose the maximum value of maximum CJ minus ZJ value. You can see that 10 is the maximum value. This is the max value at stage 2, and so this is the key column. So this is the key column, this is key column. So what you will do, key column, divide contribution quantity by key column, maximum value, so it is a key column. So every stage you will determine the key column first. So 800 divided by 3, you will get, it is 266.7. Similarly 300 divided by 2, it is 150. Similarly 350 divided by 1, it is 350. And here 200 divided by 0, it is infinity. Then again you have to choose the minimum ratio. Minimum ratio is this much. So it is the key row. And what is the intersection element? Where the key row and key column intersects. So this is the intersection element 2. So this is the intersection element. Intersection element shows that now S2 is the at this stage S2 will be the outgoing variable and X1 will be the incoming variable in this matrix. Now we will again make a figure. This process is repeated unless and until you get the optimal solution. And where you will get the optimal solution, I'll tell you where you have to stop. Same thing. Now values are 10, 20 and all zeros, Z values. Now in this case, till now, the main objective is we have to determine the optimal values of variable or decision variable x1 and x2. So, and so here we have got, so what will be x1 will be replaced here. Instead of s2, it is your x1 and the coefficient of x1 is 10. So it is 10. So now what we will do now, divide each element by this element 2. That means 2 by 2, 0 by 2, 0 by 2, 1 by 2, 0 by 2, minus 6 by 2, 300 by 2. So all if we divide, we will get 1, 0, 0, 1 by 2, 0, minus 3, 150. So this row we have completed. Next we compute the same process repeats. Then for first initial for S1 row, what is the S1 values are 3, 0, 1, just immediate one. We will consider this one. Forget about the first one now. Then it is 3, 0, 1, 0, 0, minus 2, 800. Note down, this is 3, 0, 1, 0, 0, minus 2, 800. Then what is the rule? Minus intersection element of that row. What is the intersection element of that row is? It is your 3. So it is minus 3 into this value is 1, 0, 0, 1 by 2, 0, minus 3, 150. It is 1, 0, 0, 1 by 2, 0, minus 3, 150. So if you solve it, you will get 0, 0, 1, minus 3 by 2, 0, 7, 350. Put all the values here. So here it is your S1 coefficient is 0. And here you put all the values you got it 0, 0, 1, 0, 0, 1, minus 3 by 2, 0, 7, 350. Likewise, you fill the other columns also. It is 0s3. It is your 20x2. So it is, if you follow the rules, you will get 0, 0, 0, minus half, 1, 3, 200. Similarly, for this one, you will get 0, 1, 0, 0, 0, 1, 200. So now you have filled the table. Similar, next you have to compute Cj and Zj and Cj minus Zj for all. So it is Zj. Zj is 0, 0 into 0 plus 10 into 1. is equal to 10. Here plus 0 into 0 plus 20 into 0. So you will get 10. Likewise, if you compute usual process 20, then it will be your 0, 5, 0, then minus 10. Then here Cj minus Zj, 0, 0, 0, minus 5, 0, it is 10. Now the same rule, which one is the maximum value out of this? This 10 is the maximum value, so it is the key column. Key column. So dividing the contribution quantity by key column element, that is 350 divided by 7. So it is 50. Similarly here you will get minus 50. Here 66.7, it is 200. Now minimum ratio means this is the minimum ratio, it is the key row intersection element of key column and key row, it is your, so S4 is the incoming element and S1 is the outgoing element in the new matrix. Similarly you prepare the next matrix. So you can see that how many iterations here we are working out, though the process is simpler but it is lengthy. 10, 20, 0, 0, 0, 0. Next is the contribution quantity. And then is the minimum ratio. So now first we will replace, so this is the, so S4 is the incoming element, so we will write, instead of S1 it will be your S4. S4 is the incoming element, its coefficient is 0. Then divide, same process, divide each element of this row by 7. 0 by 7, 0 by 7, 1 by 7, minus 3 by 2, 7, 0 by 7, 7 by 7, and 350 by 7. So all, if you do it likewise, same rule followed. So it is 0, 0, 1 by 7, minus 3 by 14, 0, 1, it is contribution quantity 50. And similarly same rule we have to follow for all. So you will fill all the rows, 1, 0, 3 by 7, minus 1 by 7, 0, 0, 300, then 0 x 0 s3, 0 s3, 0, 0, minus 3 by 7, 1 by 7, 1, 0, 50, then 20 x2, 0, 0, minus 1 by 7, 3 by 14, 0, 0, 150. So we have filled the tables. Now you compute Zj and then Zj minus of Cj. Zj then Cj minus Zj. So if you solve it 20, 10 by 7, 40 by 14, 0, 0. 0, 0 minus 10 by 7 minus 40 by 14, then 0, 0. We got it. Now again you can see that at now all the Cj rules is that all the Cj minus Zj values you have to choose the maximum value. But when it is coming all Cj and Zj values are negative or 0, here you have to stop. All Cj and Zj are 0 and negative. Thus, hence this is the optimal solution. Hence, it is the optimal. Hence, it is the optimal solution. So, optimal solution. What is this optimal solution? X1. What is the value of x1? X1 is equal to, you can get three contribution quantity 300, and x2 contribution quantity, it is your 150. So, x1 is equal to 300 units and x2 is equal to 150 units. So what will be the Z? Z is equal to 10x1, that is the maximum profit, plus 20x2. If you put the values, you will get 6,000 rupees is the value of Z. And here you got x1, x2 from here. So this completes your simplex problem. You can see that how easily you can solve, but it's a time taking process, but it's very easy based on mathematical formulas. You can work out so easily. And this problem you can also work out by the graphical method also, because it involves only two variables. So this is the process of working out your simplex method. In the next video, I'll teach you about the minimization problem. This problem was dealing with maximization. So 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 next class we will be dealing with minimization problem.